Welcome to Ladyada. You made it.
I fell in from the sky.
Yeah.
This chair.
I was trying to time it, so.
Hey everybody, and welcome to another desk of Ladyada, doing all sorts of tronics here at my desk. This week was a lot of DAC stuff because I was like, well, let's do an easy DAC, let's do a hard DAC. So let's start with the easy DAC. So going to the overhead. I've got the PCM 50. Thanks to Mr. Ladyada who fixed the light so it's not shiny above me. This is the PCM 5102A, this is A revision. So these DACs are a good option for line level output from I2S. With one nice thing about them is you only need to give them like, I think maybe 3-volt power and the 3 signals, and then you get output. It has a built-in M clock generator. You can have an external M clock. This is the SCK pin, and they have stuff like format, and you can do I2S or like left justified, de-emphasis filter, another 3-volt 3-volt output. But for the most part, you actually need like a couple 3 pins to control, which makes it great for use with like any microcontroller or like a Raspberry Pi, which doesn't always have M clock output. So that's cool. So I got these in and I was testing them out. And the way I was testing them, let's see if I can bring this over. It's hooked. Oh my God, this is totally hooked onto like 50 cables. I don't think my scope, my scope probes won't make it. So let me pull them out. We'll scope the stuff later. So I'm testing it with an RP 2350 feather, and I just have it wired up to the clock, data, and bit clock, the word clock, bit clock, and data input lines. And then I'm having these little speakers they're line-in speakers. One of the annoying things about line-in is, you have to have a separate amplifier to look at the audio, because you can't plug in headphones because they're not, if you plug in headphones, you get a really distorted output because it's trying to drive 16 ohms. And these can only drive, the PCM can only drive 1 kilo ohm loads. So really, it's like a line-in only. So that works great. And on the code size, if you go to the computer, I'm using audio PWMIO. I'm overclocking because I'm using the volume control because it was like a little too loud. It was one thing that's interesting is it really gives you 3-volt peak-to-peak output if you have like the max volume. So, and the audio is like maxed out at the whatever MP3 or WAV file that you normalize to like 1.0, right, max volume. So making it a little bit quieter. But the nice thing is that this works really good. So let me find the cable, which I just had. And so it's it's going to loop. And you can go to the oscilloscope if you want. Yes, this is actually pretty good. Cool. Yeah, I think that I realized is the volume control on these speakers actually changes the load, which is terrible. So that's one channel. It's pretty clean. One thing is audio, especially when the volume is really low, when the DAC isn't really good because there's this hissiness, and it's like really, really obvious. There's like a buzz or hiss. I think I did a good enough job with this design where it's very clean. And this, to be honest, this DAC chip is like $1. It's not very expensive, but I think it'll be great. And then what I might do is, some of the other designs that we did for DACs, like I've been meaning to do like a DAC feather wing and like maybe a DAC picobell and stuff. So I would use this chip. This chip is like inexpensive and easy, but again, only has a line out. So I did book these because it's good to have just even for line out. That's a useful chip. But the next thing is I'm attacking that TLV. Okay, you have the computer.
Yeah.
And then I just realized, I think, where's my TLV chip? Oh, here's. attacking the TLV 320 DAC 3100, which is the chip that we did a great search on for last week. And this chip is amazing, right? It does like everything. It has like a mini DSP built in, so you can do like equalizer stuff, on the fly. It has, of course, volume control, beep generation, headphone driver, Class D output driver, interrupts, over temperature, like blah blah blah. It's just it just does like infinite stuff, and it's like it's designed for like a full laptop or product. It's great, it's wonderful, but like the configuration is like psycho. There is, I mean, the PLL has like 10 registers. I mean, it's great. I mean, I really just want to see if I can figure out how to make it so that M clock comes from the bit clock and is generated. So hopefully I'll be able to figure that out. But there's just like so many registers. There's like the interrupt pin is this pin, that pin, input, output. It latches, it doesn't latch, it has sticky, it's not sticky. That there's like so many configurations. So I'm doing it in Arduino first, and then I kind of throw it at Liz and Tim for porting into CircuitPython. There's a Linux driver, but of course I'm not going to be able to use that because I need it to run on microcontroller. And I kind of wanted to write, there might be ones out there, but I kind of wanted to write it from scratch. So I could also, like, as I'm going through the registers, I kind of like see what it can do and understand it. And there's others in this family, like there's ones that have stereo head, like speaker, and ones that have like mono. And then there's ones that are like the ADC, they're the input, and there's ones that do both input and output. So I wanted to sort of make sure like also that whatever library I wrote would end up working for the AIC version, which is the input and output. So it has a microphone, it has stereo line in for microphone input, and then of course has headphone or speaker output. So it's kind of an all-in-one DAC. And then by the time you're getting into complexities like that, you have to have a full I2C configured DAC. One nice thing about that PCM is no configuration. Like you just turn it on and it instantly just works, and you're happy about your life, and you don't have to, whatever chipset you are writing it for. Like if you want to use it with Zephyr, you want to use it with Linux devices, you want to use it with, your PIC32. It'll always work because there's no config. So there's a lot of registers. So what I've been doing is I'm, going through and doing the setters and getters and register and the class definition with Claude, which is working great. Love Claude, my bestie. Definitely faster than ChatGPT. Like I went back to ChatGPT 4 because I could go back and like check out how it does, and it was like so slow. I was like, I'm dying. One of the things that was driving me a little crazy was Claude has both a small context window and message limiting. The things actually was getting me with the message limiting. It's like I would be like running along and I wouldn't notice there's a little like teeny like 4-point text that says you have 3 messages left, and then like you don't know until you're like it's like you're done, and then I can't even get it to summarize so that I can like say just like you were kicked out for 4 hours, and I was like, this is such a bummer. And then Mr. Ladyada suggested, oh, you can just use a desktop API client. So I was like, I'm going to do that. So I downloaded an API client, and so I'm using that. I did get limited at the end, but it was not a message limit. It was like an input token, which I'm not exactly sure why I was getting that. Maybe the API client was like sending too many tokens. But I just started a new chat. And to be honest, what's interesting is because it was not message limited, I did eventually run out of context. It eventually started like printing out like weird values for the registers. And I was like, yo, you're getting all the bits wrong. And then I realized it forgot the context were in the first message I gave it the data sheet. And that like fell out of the window. And so I didn't know. So now actually, I was thinking about it like, I don't really need to read the whole data sheet. What I do is I just paste the table for each register as we're doing it. So
it's weird. It's like a Y2K overflow. It's weird that it gets filled up and then it starts really.
Here's the thing. I don't really know.
Yeah. I don't think anyone knows.
No one knows. So I just give it the table, and even though it's like pasted from the PDF, it's parsable enough that it was like, oh, okay, and it knows how to do the type def and nums and stuff.
So for these, the different ways you're doing this right now, if anyone in the chat knows of like a really good educator or instructor that does all this stuff and like shows video. Like it'd be neat to see someone using a API interface like Ladyada is doing,
Yeah.
and like all the tips and tricks for using it this way. Like there's not a lot of people using it this way. Certainly not showing their work. So if anyone knows like a resource or really anyone who's like doing this level of stuff, let me know.
I do like, one thing I like about Jen is I like it gives you these like prettified code blocks. I prefer these to the side by side. I hate the side by side code thing because it gets like really confused. Like it'll it's great for the first few and then it starts like freaking out. And I tell it in my instructions like only give me the changes. Don't give me the whole file. Just say like in this case, it's like, here's the functions, and then it's like, here's what you put in the header. And it's just a lot of copy and paste, and that's fine. I mean, like, one day maybe I'll have a magical thing that can scrape this and paste it into the file for me. But this is fine. And then, yeah, like I probably could use cursor, but like,
Yeah,
I'm just using this for now. And you know what? This works for me.
that's
And,
cool. As you could keep
and the
trying
thing is,
different
it's
things.
I don't know how much faster it would be to use cursor because I do have to read through it all and I check it against the data sheet. So one thing I'm going to get is another monitor so I can like have the data sheet and I can like scroll and check it because for smaller, so this is enormous. I mean, this is like we're getting into like it's probably going to be like 100 functions in the end because there's so many setters and getters you need for like all of these different settings. Um, but for smaller ones, I could just upload the data sheet and then I would just tell it like, okay, give it to me, and then I would just check it against the data. I'd have the data sheet on the side. I would just check it back and forth because it does make mistakes. There's quite a few times I'm like, no, that's a bit two, not bit one. It's the bit width is three, not four. Like it gets weirdly confused sometimes. So, and then of course, every time you start the chat over, it's like, you have to reset the context. So it's happening. So I'm trying Jan, which is like this open source, API, and then I made an API key, and then so far it's like a couple dollars basically. Instead of like your $20 flat fee, I think this driver will end up being $10. And it's like 2 days worth or 3 days worth of work. That's okay. It's still like totally worth it for me compared to how much it would cost in my time to handwrite this or to have somebody else write this. And I'd have to still QA their work anyways. So um, still I'm loving Claude. Claude's great. Also asked for suggestions for a serger for a friend. Came up with a great advice. Okay, so that's
Cool.
oh, let me show really quickly the board that came back so you can go to the overhead. So this is the board. So right now I'm actually just doing the I2S like set and get and doing like really basic, like, oh, I want to test like the GPIO pin, for example. And like for that I can just use I2S, but once I get this going fast, I will again get this running on like something like the Raspberry Pi RP2040, 2350, or Feather M4, whatever, ESP32. But it should be portable. It should work on anything, and I think it's a great DAC. So looking forward to using this. Okay, how are we doing on time?
You're at the 14-minute mark.
Okay, let's quickly go to Fusion. Okay, go to computer. So we carried this really cool product, which I actually kind of liked. It was this like add-on board that you'd plug in a compute module into, and it would turn it into a little camera. And actually really liked this little board. I thought it was cute because it was like the same size. And I think a lot of people did want to use stuff like the Pi camera with the compute module 5 and 4. But one thing that happens a lot, and it's like, I don't know what's going on, but we'll buy stuff, especially from small makers, and we'll stock it for like a year or two. And then they'll kind of slowly but surely not respond to our emails. And then eventually their website goes away, and then eventually, or like the SSL certificate doesn't get renewed. And then eventually their website goes away, and then eventually gets registered as like a porn site. And it's like, I never hear from them again. I don't know what the deal is. Maybe they hated electronics, maybe they moved on with their life. It's part of the deal. We stocked it as long as we could, but like I said, they were no longer replying. I was like, you know what, this is a good opportunity for me to maybe go in and design something close to this, inspired by, but clearly not the same thing, right? I don't want to design the same thing. They've already done that. So I sent Tim on, friend of the fruit, on a journey to design this board, which I can't do the assembly. I don't want to risk opening the assembly. Maybe I can. Hold on. Oh, no. What did I click? It's thinking.
Now you've done it.
Oh, okay, here you go.
You just burnt down a forest.
I know I did. Pan orbit. Okay. No. pan. This is pan. Can I rotate? Okay, great. So this is what the he came up with, and this is just a Rev 1, and we might adapt this later, but this is a board that plugs into the compute module 4 or 5, although it's kind of like best for the 5 because there's a lot of cool things that they added in the 5, like separate USB host. And so there's a 3.0 USB connection, there's a real-time clock, there's HDMI output, there's a stemma QT, there is, this is actually an I2S connector that he added because the first Rev didn't have it. I was like, oh, you know, what if people want to have a little TFT screen? So it's like, oh, maybe add an I2S and then we could, you know, connect it to a TFT. Or also it gives you like a bunch of GPIO, a bunch of I2C, SPI, power, you know, if you want like more pins for external connection. 2 GPIO buttons, shutdown button, which will also be a power, a GPIO button because the power is only for CM5 and the end it's a little flippy switch. This is the gadget USB, so it could be USB host, but it's better if you just use it for like you connect in and you can load code onto it. And then I lost the orbit. And then there's also there's a micro SD card slot here for the CM Lite because it doesn't have the memory in it. And there's DSI connector, and there's also a fan connector. Here you go. This is the, it looks just like a stemma QT, but it's fan. Oh, it's hate. It's like the same connector, but what are you gonna do? Anyways, the goal is to make something kind of inexpensive. And then yes, there's still the mounting holes, and then you can take the camera and plug it in and then mount it on the top. So it could be like a little camera thing. So Timo designed this and he's using Fusion, which I've never used, but this is basically what Eagle got like merged into as an unholy like genetic mutant. So, you know, I'm in
Like
this.
species?
Yeah, this is like species. Oh no, it's out of sync.
One time I mean more species.
Yeah.
All of them in a row too. They got worse as the series.
I don't think I made you watch me more than one. So this is what Eagle basically became Fusion, and it's actually kind of funny because it's like it's all kind of here, but it's like named something slightly different. So they have like Polygon, and they have all the things. It's just like weird, like layers is over here. I mean, I'm thinking like, should I just use this when Eagle gets discontinued? Because it's not that different. It would probably be easier for me to learn Fusion electronics, which is like basically Eagle, than to learn KiCad. But I don't know. At least this way, there's like I have like my licenses for Fusion, so I can always use Fusion. But so I was observing. I was also using this as an excuse to like, oh, I'm gonna like try out like looking at this. So it's a 4-layer board because you know those Hiroshi connectors, those connectors for the compute module are really high density. This is looking good. You know, one thing is it's like you could always add more stuff to this, but we also kind of wanted to not make it like everything. We wanted to make it like useful, not everything in the universe, and like I want to keep it inexpensive. Like I didn't want it to be like I have a rule where it's like I really don't like when the accessory is more than the thing, and so like a compute module was like $35. I really wanted this to be $35 or less. So we're gonna aim for that. So this is just the design. The revision isn't finished yet. I think there's like two more things he's gonna do, and he'll book the PCBs, and then we'll try it out, and I'll get I have to get the components, and I'll also book the PCBs, and we'll try it out. But really cute little board, and then yeah, you can see how it plugs in. I guess this is the model of the compute module or something, but yeah, but this is basically the top. So yeah, we'll see. I just thought that would be fun. Like Tim, I was like, oh, can I share this? And he's like, I never get to share anything because everything's under NDA. And I'm like, that sucks. So I was like, let's shut up. So if you want to hire someone to do engineering for you, Timon is a contractor, and he works for lots of people. So you can hire him to do this kind of work. Okay, I'm gonna. What time are we at?
You're up to 20 minutes.
Oh, great. Let's go to the great search.
Okay.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you so much, DigiKey, for making this possible every single week. Ladyada uses her power of engineering to help you, yes, you, find the things you want on digikey.com. Ladyada, what are you looking for this week?
Okay, well, this week I actually learned something important I wanted to share with you guys, which is so you got the compute module, which DigiKey stocks. So if you want the compute module at a good price, it's $40 for this version, which has like lots of RAM and MMC. They start at 40 and they go up to like $100 easily, I'm sure. 2 gig of RAM, yeah, 4 core, very fast. So this, and we're designing with Tim on, or like Tim's doing the design. I'm just bossing around. This, let me see if I can get back to that 3D model. This backpack that would fit on. So this is the schematic. Oh, this is the little cube. This little backpack that would fit on the back of a compute module. You can see the compute module plugs in. He did a great job doing this 3D rendering to make sure the clearances were good, because we need to fit a bunch of stuff between the two. And you see these two mating connectors right here, like in the middle. And I was like, oh, what connector do we use? And like, how much clearance do you get? And he said, oh, in order to fit some of these connectors and make sure we don't bump into any components. Also, there's going to be like a compute module 6 and 7. Like they don't stop. The Raspberry Pi Foundation comes up with new stuff every year. The more clearances, the better, because we don't want anything on our board to touch components on the compute module, because if they add a capacitor there or a connector or whatever, and our board doesn't fit anymore, that would be sad. So the more clearance, the better. So I said, oh, the connector we should use is this Amphenol that is 4 millimeter height. And I was like, I thought it was a Hiroshi. And that's when he said, yeah, it used to be. And so I want to show you something important. If you go to the Compute Module 4 datasheet, this is the Compute Module 4, the previous version, which is still very, very popular. And it was the first, I think it was the first in this new format. The CM3 was still in the so dim format. This is in the like plug-in format. It has a ton of GPIO, which is great. They used the Hiroshi DF40 series, and DigiKey does stock these. They're 0.4 millimeter pitch, so a little bit of a pain to solder. They have 100 connectors each, and they come in this format, which is, you can tell it's tall, and they also come in this format. Oops, cool in there yet. Second. Yeah, it's like, which height do you want? Super skinny flat, which is, pardon me, which would have no clearance. And so just watch out. It's not like there's anything wrong with having no clearance. Just be aware, if you have the no clearance version, there can't be any components on that side with the compute module, because it would sit like essentially flat against the board. So, but in the Compute Module 5 datasheet, there's a different connector recommended, because the CM file, I think, the CM5 has more stuff on it. It's just like more packed. You need more clearance, so they're like, don't have the 0 clearance version if you can of that other version. You want 1.5 millimeter stacking height, because the CM5 just has I think has a couple more millimeters. They're like, don't get the lowest possible. You want at least 1.5. So they recommend the Amphenol 10 series. So let's see what's available. There's a couple different ones. Yeah, there's the 4 millimeters and 1.5 millimeters. So the 2 versions available, these are called the Berg stack, and you can see they're like, this one is quite short and this one is a little taller. Even, it sounds like, I kind of assumed that the Hiroshi was like, those were the only connectors, but it turns out you can also use these Amphenol Berg stacks, and they will mate with this. And I was actually asking Tim on why, and he said, like, well, first off, you get the extra height, but second, these are better, have a little bit better power transfer. Maybe the pins are plated a little better, or maybe there's just like slightly thicker pins or something, but they can pass more current. So you can use these for the Compute Module 4 as well. They're like back compatible, but if you're using the 5, just because you're looking at design from the 4, like the Compute Module 4, doesn't mean you should use that connector. You should upgrade to this, which is the 1016-4227, and then the 1004, which is the 4mm height of the Amphenol. DigiKeys have in stock, and they're actually also less expensive, which is true. I thought that was kind of cool. The Hiroshi's are like $2. These are $1.35, $1.50 in quantity. So this is my pick. It's a short, great search, but I think this is going to be very handy for anyone doing upgrading a design from the CM4 to CM5. Check out this part for connecting your modules to your main board.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Alrighty, everybody, we'll be back all throughout the week. We got shows, we got electronics, we got all sorts of amazing fun things that'll bring people together to show and share their projects on things like the show and tell, or publish their guides on playgrounds, or just figure out ways to find common ground and build together. We'll see everybody later.
All right, thanks everybody.